Bismillah Rahman Rahim. Assalamu alaikum everyone. Welcome to ASTC. This is Cambridge A Level Mathematics 9709 Mechanics. So today we will be starting with the introduction of mechanics and what mechanics is all about. So our first subtopic is mathematical modeling. Okay. Now before we go deep into the concept of what mathematical modeling is all about, let's first understand what mechanics is. Now mechanics is that branch of applied mathematics which helps us in understanding the laws of physics, and we can also apply mathematics to the physical situations that involve forces and motion. Through this, what can we achieve? We are able to calculate the forces that are involved. Okay, we are able to calculate the speed or the velocity of an object. We are able to calculate what the acceleration of an object is, if it's moving in a straight line or if it is moving, if it's not if it's a constant acceleration or if it's a variable acceleration. Okay, now mechanics can be divided into three sections. Okay, the first section is kinematics. The kinematics is the study of how objects move, okay, which involve the speed, velocity, acceleration, displacement, distance, time. So all these variables, okay, these are related to the kinematics of an object. Okay, now when we are dealing with kinematics, we do not discuss the forces because we only look at one aspect at a time. Okay, we do not look everything at once, but we just break them down into different sections. The next part is dynamics. Okay, the dynamics tells us that tells us about the study of why objects move. Okay, so in dynamics we consider the forces. In kinematics we consider how the motion of an object is. Okay, that means the speed, velocity, and all those factors. But when it comes to dynamics, we do not discuss mostly about the velocity or the distance. Okay, rather we discuss on what forces are causing the object to move. Okay, now these forces, they can either change the motion of an object. Okay, so for example, the brakes of a car, they allow the car to decelerate and then to come at a lower speed, not necessarily stopping the car, but the car might start moving at a lower speed. Why? Because of the force that was the force that was acting on the object. Okay, then the third section is about the statics. The statics is about the study of objects which are at rest. Okay, now what does that mean? When an object is at rest, there could be two things. Either there is no force acting on an object, okay, or the forces are acting on an object, but the forces are opposite to each other and they have been balanced out. So therefore there is no resultant force on an object which causes it to move. Okay, so those of you who have come from the background of physics, okay, might be familiar with the Newton's first law of motion. The Newton's first law of motion is all about statics. Why? Because it tells us that if an object is at rest, it will continue to remain at rest unless an external resultant force acts on it. Similarly, if an object is moving in constant motion, it will remain or it will continue to move in constant motion unless an external force acts on it. Okay. Then comes the part of modeling. Okay, modeling basically means that we have a real life situation in front of us, and how can we make a model based on that real life situation? So, if let's say that you want to work out that, let's say a car is moving, okay, on a road, and suddenly it looks at a traffic signal and now it has to stop. If you want to find out that how much time it is going to take for it from the time it starts to apply the brakes till the time it stops. Okay, so for that particular problem, okay, or for any problem of that sort, we can first model the situation. Okay, now modeling basically means that the very first step is that you make a clear diagram, okay, and then you start listing down what do we know about the car, what do we know about its initial speed, what do we know about the distance that it has traveled from the moment it starts to apply the brakes to the moment it stops at the traffic signal. Okay, how much time does it take? Okay, and okay, that's something that we need to find out, right? That how much time it's going to take. Other than that, what other factors can we list down? Okay, what assumptions can we make? Because sometimes there are so many factors involved in a real world situation that you cannot directly solve the problem. So what do? We make the assumptions so that we can first simplify the problem so that we can deal with some of the aspects of the problem one at a time. All right. So the modeling process is something like this. This flowchart gives you a sequence of the steps involved. Okay. The very first one is identify a real world problem. Okay. So for example, in our case, the problem is the car is moving, okay, and it sees the traffic signal, it stops at the traffic signal. You need to find out that how much time does it take, okay. Then we make assumptions to allow simplification of the problem, okay. That leads us to arrive at a mathematical model. Using that mathematical model we can solve the problem, okay. Then we interpret the solution. So for example, we find out the time. Now this is something that we modeled. How about doing this in a real world situation? Okay, so there is a car that is moving, okay, and you have a timer with you. So the moment the brakes are applied till the moment it stops at the traffic signal, how much time does it take? Okay, you compare that with what you have calculated, okay, and then you will try to brainstorm on what could be the improvements in the model, okay. That will allow us to make improvements, evaluate, and then we can arrive at a better mathematical model. So this is how scientists they work on different problems, okay. First they make assumptions to simplify a problem, and then once the problem has been simplified, then what happens is they test it, they test their model, okay, on how accurate results it is able to give, okay. Then so as we discussed that there need to be some assumptions for our mathematical modeling so that we are able to solve the problem or at least solve some aspect of the problem. So in almost all mechanics models, a diagram should be drawn indicating any forces and motion. Assumptions need to be made when modeling to enable a problem to be simplified. So what are the common assumptions that we include? Sometimes when we are looking at a particular situation, so we can ignore friction. For example, if you have an object and an object is falling from a building, okay, let's say that there's a ball, you drop a ball from the top of a building to the ground. Now you need to work out that, okay, what is the final velocity of the ball when it hits the ground, okay. For that purpose, to make our life simple, what we can do is we can ignore friction or air resistance. In this case there will be air resistance, okay, and that's the second aspect that we can ignore, okay. Friction is usually on a horizontal surface. When your object is moving on a horizontal ground, that is when we take into account friction. But when your object is moving in vertical motion, okay, if an object is falling from a certain height, so that is when we ignore air resistance. So air resistance is a kind of friction, but it is more specific to vertical motion. Also, air resistance is it also acts on horizontal motion as well, but friction is more like, let's say that a car is moving on a road. So what is the friction between the tires of the car and the road? That is where friction comes in. And air resistance, that is like the movement of air that opposes the motion of an object. So yeah, kind of it is applicable in both horizontal and vertical motions. But when we are talking about the opposing of air to the object, that is when air resistance comes in. Then treating a body as a particle. In all our calculations, mostly, okay, what we will be doing is we will be treating our object as a single point, a particle, okay. Why? Because obviously every object has its own dimensions, right? A car, for example, has its own length, has its own width, has its own height, okay, has its own mass, okay. So that will actually make our calculations a bit more difficult, a bit more complex. Why? Because then we will have to take into account all of these factors. So one of the assumptions that we do is we treat our body as a particle. Okay, so particle means it has no mass, it is a single point, it has no dimensions, it is just one single point, and on that point you are seeing that what forces are being applied on that particular particle. Okay, then ignoring small dimensions, for example, in a lamina is a flat 2D piece of sheet, you could say. Okay, so like for example, let's say a paper. A paper has a very small thickness. It is so small that we can just ignore it. Okay, then ignoring the stretching of an inelastic string when a load is attached. This is actually one point. Okay, now when you attach a load, for example, a spring. If we take an example of a spring, if you start applying some mass to the spring, to one end of a spring, it starts stretching, right? Or even a rubber band, if you hold a rubber band and you start pulling it from one side, what's going to happen? It's going to start stretching. So when we say that we are using an inelastic string, so we are basically saying that the string has a constant length, it does not change, okay, it does not stretch. So basically what we are doing is we are ignoring the stretching part of an object. Okay, so definitely we are not going to use any object that is able to stretch, but still let's say that even some rigid objects, if you apply enough force, their length uh, could change. Okay, so these are some common assumptions that we make when we are dealing with problems in mechanics. Then the next part is to understand the terminologies which are used. Okay, in the questions in exam papers, they will use some terms which have certain meaning, and they expect you to understand that meaning so that you are able to make correct assumptions for the particular problem. Okay, so let's look at some of the terms. Rough. Now, when there is a rough surface, okay, this is usually referred to when you have a surface. Okay, so what type of surface is it? Is it a rough surface or is it a smooth surface? Okay, now a rough surface means that you cannot ignore friction. The friction has to be taken into account. All right, and a smooth surface means that friction can be ignored. Friction is very less, so it is so less that you can just simply ignore it. Okay, and what do we mean by friction? Friction is the opposing force to an object. Okay, so let's say that if the friction is less, that means the surface is going to be smooth and slippery. Okay, when there is less friction, the surface is smooth and slippery. Okay, and when there is a rough surface, so it is not very easy for an object to move through, to move on the surface. Okay, then an object could be thin. So thin basically means that the thickness is negligible. Particle, okay, this I've already explained, that a body whose dimensions are so small compared with any other distances involved that it can be represented by a single point. Lamina, a flat object whose thickness is so small compared with its length and width that it can be ignored. Then a rigid body. A rigid body basically is referred to a type of object on which if you apply force, it does not change the shape of an object. Okay. Then we have a light rod. Light, basically in terms of mass, it tells you that the rod is so light, okay, that you can simply ignore the mass of the rod. Okay, so we only assume that it has a certain length, okay, and we say that it is so light in mass that you can simply ignore it. Then a uniform rod. Now there are two types of you can say objects. Okay, one we can say a uniform object and the other is non-uniform. Okay, a uniform rod refers to those objects which are regular shapes. So for example, you have a rectangular ruler. Okay, so that ruler has a center of gravity or a center of mass at the very center, the exact center, but not every object has that property. Okay, because sometimes you can have an irregular object, for example a stone does not necessarily have the center of mass exactly at the center, might be a little bit on the right, a little bit on the left, depending on what the shape of the stone is, because the stone is not a regular shaped object, it is an irregular shaped object. Okay, so uniform rod refers to those objects that have equal lengths. Okay, sorry, those objects that equal lengths have equal masses. So if let's say that I'm talking about a 1 meter rule, okay, so 1 meter ruler. So if let's say that I'm going to talk about the first 50 centimeters, so the first 50 centimeters are going to have the same mass as compared to the last 50 centimeters of that same ruler, okay, because the mass has been equally distributed on both sides. So that's what we mean by a uniform rod, okay. And non-uniform rod, they do not have that property. Then comes inextensible string. Inextensible string means that you have a piece of rope, for example, and that rope does not stretch, okay. So when a force is applied, it does not stretch, and therefore we also call it inelastic, because it does not have elasticity, okay. Then we have light smooth pulley, okay. Now there are two things that you can see: light and smooth. Light refers to that the pulley is so small that its mass is negligible, okay. Its mass is what? Negligible. And it is smooth surface, so the friction can also be ignored. So these are two assumptions that we have made. So when so in an object in a question, they tell you that an object has been tied through a string, and that string goes over a light smooth pulley. So it can ask you that what assumptions can we make for this particular model. So there you can say that since the words light and smooth are used to refer to a pulley, that tells you that the mass of the pulley is small, and it also is so smooth that there is no friction involved. We can ignore the friction. Then we have bead. A bead is a particle with a hole drilled through so that it can be threaded onto a wire or a string. You know, sometimes you have a nut that can be placed on an object, and you rotate that nut so that it fixes onto a certain object. Okay, so bead is kind of that particle that a hole is drilled through it so that it can be fixed. Like for example, you have a screw, and you can actually rotate that bead, that particle, onto the threaded part of the screw so that it fixes onto it. Okay, so it can also be held in like in mid air, you could say. Okay, so it does not necessarily have to touch the bottom part of the screw. So okay, so even if you do not understand this part, we will be looking at some examples later on, so there it will become much clearer of what we mean by a bead. Then we have a wire. Okay, a wire is a rigid body in the form of a strip of metal. Then we have peg. Peg is a support on which a body may rest or be hung. I'll give you an example of this. You know that if any one of you have gone to camping, so you know how they fix the tents by they have like a rope, okay, and that rope goes over a wooden piece, okay. That is part of that wooden piece is in the ground, and part of it is up, right, above the ground. So you tie the rope around that and you fix onto it. So that particular part, that wood, that is called a peg. Okay, so what is it? It's a support, okay, on which a body can rest. So if let's say you have something similar, okay, even a nail that has been hammered into a wall, that can also act as a peg. Why? Because it's a support through which you can hang the objects, okay, and the object can also be in rest. Okay, so you know, like for example, when you hammer a nail onto a wall and you hang a painting, okay, so we say that the painting is in rest on a peg. So peg is just like a support. Okay. All right, so let's look at some examples of models. Suppose we need to calculate the greatest height reached by a ball that is thrown vertically upwards with an initial speed of 5 meters per second. So you have a ball on the ground and you throw it with a speed of 5 meters per second vertically upwards. How can this situation be modeled? What assumptions can we make, and what physical factors can we ignore? Okay. Now, when it comes to assumptions, since this is a vertical motion of the body, we can ignore air resistance. Okay, sorry, the ignoring part comes later on. First of all, what is the assumption that we can make? The assumption can be that we can treat the ball as a particle. Okay, we can treat the ball as a particle. So what happens is that will allow us to make that will allow us to make to do calculations in a much more efficient manner, okay, when we make this assumption. So the dimensions of the ball can be ignored and it can be modeled as a particle. Air resistance, as the ball is thrown into the air, can also be ignored. So what physical factor can we ignore? We can ignore air resistance. All right, let's look at another example. Two particles of mass 3 kg and 5 kg are attached to the ends of a light inextensible string. Notice that there are two words describing the string. The string passes over a smooth pulley. That's a third word that is describing what? A pulley. The system is then released from rest. What assumptions can we make in modeling the above situation, and what physical factors can we ignore? Okay. Now, what assumptions can we make? We can treat the two we can treat the two masses as particles. Okay, that would mean that we are ignoring any dimensions which are involved. Okay, but we do not ignore the mass. Okay, the mass is something which is important. We are only ignoring the dimensions. The masses are attached to a light inextensible string. This assumes that the string has no weight. Why? Because it is light, and it will not stretch. Why? Because it is inextensible. Thus, the tension in the string for each particle is equal. Tension is the pulling force on an object. Okay, so if let's say that you have a rope which is tied to a ball, okay, and you're holding the rope so that the ball hangs from it. So what force is being applied on the ball through the rope? That force is tension, because the rope is pulling the ball upwards. That's why it's not allowing the ball to fall down, right? So that's what we call tension. Okay, now because we have assumed that the string is light and inextensible, we can safely say that the tension in the string is equal and it is same throughout the length of the string. Like, so what does that mean? That on every part of the string there will be equal tension. Okay, that will make our calculation easier. Then thirdly, we have the pulley. The pulley being smooth assumes that there is no friction. Also, as the masses move, air resistance is ignored. Okay, so these are the assumptions and uh, the factors which can be ignored. Okay, the assumptions that we can make and the factors which we can ignore. A uniform rod of weight 30 Newton rests horizontally in equilibrium on two smooth supports at A and B as shown. Equilibrium basically means that an object is at rest even when the forces are being applied on it, right? So here we can see that we have a uniform rod. So what do we mean by a uniform rod? That at equal lengths, equal forces will be acting on it. Okay, the masses will be equal. So if let's say that between these 2 points, between A and B, okay, there is a length of 4 meter. So whatever the mass of this part of the rod is, it will be exactly the same on this part of the rod as well, because this is also 4 meters. Okay, and how do we know that? Because it's a uniform rod. So suppose we need to calculate the reaction forces at A and B. How can the fact that the beam is uniform be used to model the situation? As the beam is uniform, the weight is taken to act at the center. Okay, so that is what we can assume from it, that the center weight. So if let's say there are three forces in total, okay, one of them is a reaction force which is acting on the rod from A. Another is the second reaction force acting on the rod at B. And then we have the weight of the rod itself. So where is the where is the weight of the rod acting? Okay, that will be exactly at the center. And how do we know that it will be exactly at the center? From this, that the rod is uniform. Okay. All right, the next one is a parachutist jumps from an aeroplane and falls vertically from rest towards the ground. State any assumptions to be made when modeling the initial motion of the parachutist and any physical factors that have been ignored. The moment the parachutist jumps from an aeroplane, okay, what assumptions can we make? So the first thing is we can model the parachutist as a particle, so that we do not take into account what his length is, what is his height, okay, and so on. In this model, the parachutist is taken to be traveling vertically with no rotational or sideways motion. We are also assuming that he's falling just vertically downwards and he's not moving sideways or he's not having a circular motion or something like that. Because obviously, if we assume that, then that's going to be a lot different story. Because now in circular motion, you have different forces involved. Okay. Then we can also ignore any form of air resistance before the parachute is opened. Why? Because when the parachute is opened, now you cannot ignore the air resistance, because now the magnitude of air resistance is so much that it cannot be ignored at this point. Okay. Then comes the units that we use to measure different physical quantities. Okay. Now, throughout mechanics, the International System of Units or SI units are used wherever possible. The following SI units are most commonly used in M1. So when we are talking about distance or displacement, then it is measured in meters. Okay. When we talk about speed or velocity, it is measured in meters per second. Okay. Now meters per second, you might be used to writing in a different manner, but now you have to write it in this manner. Okay. Also, just because distance and displacement they are measured in meters does not mean that it cannot use other units. It could also use kilometers, it could also use centimeters, it could also use millimeters. So from your O level mathematics or IGCSE mathematics, you should know what the conversion factors are. So if let's say that a distance has been given to you in millimeters and you need to convert it back into centimeters, okay, so you should know how to convert that. Okay. Similarly, if you have velocity given in meters per second, but the question asks you to give your answer in kilometers per hour, so you should be able to convert them from meters per second to kilometers per hour as well. Then acceleration, that is meters per second squared or meters per second per second. Obviously, we do not write per second. Okay, but that's just to tell you that the unit of second is twice. Mass is measured in kilograms. Weight or force is measured in newtons. Momentum or impulse is measured in Newton seconds. Moment of a force is measured in Newton meter. Although the moment is not part of our syllabus, but it's only included here as an example. The last part of this lecture is the command words. Okay. Now, you might already be familiar what we mean by command words, but if you're not, you know that in exam, when you're solving questions, they ask you questions in different, using different keywords. Sometimes they ask you to describe something. Sometimes they ask you to calculate something. Sometimes they say find out or give or explain. These are the words from which your question usually starts, right? List out. Okay. So all of these words, they have different meanings. So for example, if let's say they ask you to plot a graph, and if they ask you to sketch a graph, there's a difference between plotting and sketching. When it asks you to plot and draw the graph, it is expecting accuracy from you, that your graph should be accurate, it must be measured. Okay. But when it asks you to give a sketch of the diagram, or uh, like give a rough sketch, give a brief sketch of what the distance time graph looks like, for example. So in that case, you're not expected to give accuracy, but you're only expected to show the main features on the graph. So what will be the main features? So let's say what will be the speed at a particular point, what will be the time at a particular point. Okay, depending on what the question is, obviously. So you have to draw the graph, you have to just make a sketch of that graph in that manner. Okay. So these are some command words, okay, that you must understand. So when it says calculate, it means work out from given facts, figures, or information. Okay. Describe means state the points of a topic, give characteristics and main features. Okay. Describe can also sometimes mean that you have to explain them. Okay. When you're describing them. Sometimes, depending on how many marks are there for the question, you might be expected to give a an explanation on that. Determine, establish with certainty. Evaluate is similar to calculation. Okay. Judge or calculate the quality, importance, amount, or value of something. Explain, set out purposes or reasons. Make the relationships between things evident. So let's say that If we if uh, so, so let's say that you have stated something which is quite obvious, right? So like for example, when a car applies the brakes, okay, it stops, okay, its velocity decreases, okay, and then it stops, okay. But what is the underlying reason behind that? We know that velocity decreases because that is something that we can see, right? So how we can relate to this is that when you apply the brakes, then what happens is the force which was applied by your engine is now less as compared to the frictional force between the tires and the road, okay. That friction is something which is now opposing the motion of the car, and it allows it to come to a stop, okay. That's the underlying reason. So what we stated clearly was that the velocity decreases, okay, when we apply the brake, or the car decelerates. But what is the underlying reason? Okay, why is it decelerating when I'm applying the brakes? The underlying reason is this, that now the force of friction is greater than the driving force of the car, okay. Because now when you apply the brake, there is no driving force. You have actually removed your foot from the accelerator. So now what's happening, the only force acting right now is now the frictional force. So slowly and gradually it's going to bring the car to a stop, okay. All right. Then we identify, we only recognize or name some of the aspects. So for example, a question might be that identify the assumptions that we make, okay, or identify the factors that can be ignored. So you're going to just say air resistance, okay. We can ignore air resistance, we can ignore friction, okay. So that sort of thing. Justify, okay, support a case with evidence or argument. Show that, that means provide structured evidence that leads to a given result. And you might already be familiar with this, that there were questions in in IGCSE mathematics as well as in O level mathematics, where they ask you to show that and they give you an answer. Now from your working, they want to see how can you reach to that particular answer that they've already given you. So for example, they can say show that x is equal to 1. Now whatever the question is, how you make your progress, how you start working through the given question and you reach the answer that x is equal to 1, that is what's important, okay. So that is where these type of key command words are used. Then sketch, make a simple freehand drawing showing the key features. As I mentioned, that it could be a graph, it could also be a force diagram. Now what is a force diagram? When we'll study the chapter on forces, so we'll look at that in more detail. So for example, if a car is moving, while it is moving, what are the forces acting on it? So I'm just going to draw a little bit of a circle, and then I'm going to show with arrows that what forces are acting and in which direction. So for example, vertically downward, the weight of the car is acting, okay. Then vertically upwards, the reaction force on the car is acting, okay. Then on the right you might have the driving force, okay, the force of the engine. And on the left side, you'll draw a left arrow, so that will be the force of friction, okay. So that will be a simplified force diagram. Then state is also referring to to clearly giving an answer in a concise manner, only writing what's important, okay. So for example, it can say state what happens to the velocity of an object. So depending on what the question is, you can say the velocity increases or the velocity decreases or the velocity is constant, there's no change, right? You don't have to give reasons behind that unless it says state and explain, okay. Then you have to give reasons that okay, why velocity is constant or why velocity is increasing and so on. Lastly, verify, okay. So it says confirm a given statement or confirm that the given result is true, okay. Again, based on your working, you have to reach the conclusion that whatever the statement is given, that is true, okay. Now that's the end of our first lecture. Now let me tell you something. This lecture is not something that will be assessed in a manner that they're going to give you questions and then they're going to ask you that okay, explain the modeling process or explain. No, it's not like that. This is something which is a prerequisite for you to be able to understand what mechanics is and how things work in it, okay. How we are going to approach a problem, because this is something that we will be doing in every question. We will be given a scenario, okay, and then based on that scenario we have to make some assumptions. Based on those assumptions we have to do some calculations, okay. That's the gist of it, okay. So this is not something that will be assessed in an exam. But yes, what you're supposed to know are these terminologies, because these terminologies will be used in the questions, and you will be expected to know what they mean. What assumptions can you draw from these keywords? Okay, and also you're supposed to know these SI units. Okay, what SI units should be used, and what are these command words for? Okay, so with that, that's the end of our first lecture. In our next video, we will be looking at we'll be officially starting our chapter. Okay, this was just an introduction. All right, so in the next chapter, we will be starting with our chapter number 1. And till then, take care. Assalamu alaikum.